we'll have x squareds and y squareds, or we'll just have y squareds. I'm not going to give you any x squared parabolas. Those are parabolas that open up or down. Okay? So again, you're paying attention down here if you're trying to decide. Now, before I leave this page where we have the basic equation of a circle and basic equation of a parabola, I just want to point out one thing about the equation of the circle up there that I have a little star next to. X squared plus y squared equals r squared. Does that sound like anything you had ever done in geometry?
Pythagorean theorem.
Sounds a lot like the Pythagorean theorem, right? A squared plus b squared equals c squared. So, fun fact,
Triangles are circles.
the equation of a circle is the Pythagorean theorem. Yes. And your old distance formula, d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, that's just the Pythagorean theorem. So wonderful. Yeah, it's so great. So the Pythagorean theorem is giving us all these things. Okay, so side note, that's fun to know. Let's do some examples of what we want to practice. Graphing the circles, graphing the parabolas. Okay, now you can decide if you want to write down the directions for this example in your notes. This is going to be the same directions that are on your homework tonight, and it'll be the same direction for all three examples that we do together. So basically, we want you to graph the function. But in addition to graphing, you should be able to identify things. Now notice in the directions, it gives you two options. If it's a parabola, identify the vertex and the direction it opens. If it's a circle, you're going to identify the center and the radius. And then for both of them, we want to still be able to identify domain and range because, hey, we're in Algebra 2. Well, I would do all of those extra things, the identifying, after I have a graph. It will be easier to see. So let's look at the first equation that I've given you, x minus y squared equals 2. First thing I would do is figure out, like, what is the shape even going to be? Lilith says a parabola because it has one squared term, not two. So we know this is a parabola. I like it. Okay. Now, remember the parabola equation that I gave you, the basic one, was just, x equals y squared, right? Someday I'm going to get it. X equals y squared. Okay, so what I want you to do is, like, get it to look like that. Get y squared all by itself, okay? So I'm noticing on this one that y squared is negative. I never like my squared terms, like my leading terms, to be negative, so I'm just going to go ahead and add it to the other side. So that would be x equals 2 plus y squared. I'm just like rearranging things algebraically. And then I still want to get y squared all by itself, so I'm going to subtract 2. So I get y squared equals x minus 2. And I also like to plot the sides there, which I'm allowed to do. Okay, now we don't know a lot about y squared equals x minus 2, but now we're going to make the big connection to why we're doing this in chapter 5. If you wanted to solve for y, because most of the time I ask you to graph things like f of x equals, y equals, how would you get y all by itself? Square root both sides.
Oh, wow.
Now, if you take the square root while solving an equation, what do you have to remember?
Both sides.
You got to do it to both sides. There has to be a plus or minus. And now you can start to see the connection to chapter 5. Why would I learn this in chapter 5? Because it's really just a square root graph. And in fact, it's really 2 square root graphs. Okay, so I'm going to draw a little arrow here. It's y equals the square root of x minus 2, and y equals negative the square root of x minus 2. How are those two graphs related to each other?
They're reflections of each other.
Reflections in the x-axis. Yeah. Okay. So, if we wanted to graph them, I'm usually just going to start with, like, the positive one. What transformation has to happen? It's got to go right 2. I'm gonna plot my starting point for my square root graph, right 2. And then remember my little thought bubble. I'm always thinking about, okay, I would have 0, 0. I would have the point 1, 1. And I would have the point 4, 2 on my parent graph, right? So I can just move with those same counts. Because there's no stretch or shrink. So I'm going to go up 1, right 1. I should have a point at 3, 1. And I'm going to go up 2, right 4. So that's like what? 1, 2, 6, 2. And someone said the day we did square roots, it looked like half of a parabola. Liam said that it looked like half of a parabola. And we said, okay, well, we're not going to have the other half because we wanted it to be a function. It had to pass the vertical line test. But today, when you solved, you had plus or minus, so now you have the other half. Just reflect these points over the x-axis. Sideways parabola. Voila. So it's a square root graph, and then you just graph its reflection, and you have a parabola. No, I'm following these. So from my starting point, if there's no stretch or shrink, I can go up 1, right 1. That's my first point. So I just went up 1, right 1. And then for the next point, if there's no stretch or shrink, the next one would be up 2, right 4. That's what the parent graph does. And I'm literally just sliding the parent graph right 2.
Oh,
Okay, now let's talk domain and range. Oh wait, I haven't done my vertex and my opens, right? What's the vertex of this parabola? 2, 0.
Yeah.
What direction does it open? To the right. What's the domain? X's that are greater than or equal to 2, because 2 is the first time it works. That's our vertex. And then everything shows up on the right side. And what about our range?
All real numbers?
TJ, why did you say all real numbers right away?
Because since you know it's a parabola, it's always going to continue going in like that direction. And if there's one going upwards and one going downwards.
Yeah. One's going higher towards positive infinity. One's going lower towards negative infinity. So we're going to get all real numbers. If you remember back to chapter 2 and 3, if we graphed up and down parabolas, these things were flip-flopped, right? The domain was all real number, and the range was always restricted by the vertex, the min or max. Okay, so that's going to come back to us later when we learn about inverses. In section 5, 6. Yes, Charlie, yay! Okay, does anybody have any questions before I leave this example? Okay, we're going to do another parabola example because there is one thing I want you to see. You don't have to rewrite the directions because they're the same direction, so just write down the new equation. We're going to do the same stuff we just did. X plus y squared equals negative 4. And we would say this is which shape? Parabola. Because it was only a y squared. And remember, what did we do first?
You got the I by itself.
Yeah, isolated the y. Rearranged things so it was something that I could graph. So I'm going to say y squared equals negative x minus 4. And then I'm going to take the square root of both sides. So I'm going to get y equals plus or minus the square root of negative x minus 4. Now, generally, I don't put those horizontal stretch or shrinks or reflections in there for you. I try to avoid those if possible. But we do want to see some parabolas that open left. So this is a good time for us to look at this. Do you agree that the negative in front of the x means that there must have been a reflection in the y-axis?
Yes.
Okay, so when you think about, okay, that other one open to the right, now we're going to reflect it. It's going to open to the left. Okay. The one thing that you have to be really careful about, in order for you to get the right, left, right shifts, you have to factor out this negative first. So I'm going to write it again. Y equals plus or minus the square root of negative. And then it looks, because it says minus 4, it looks like it might be going right 4. But that reflection in the y-axis has been applied to both of these numbers, like it's been distributed. So I have to factor out the negative. What's left over? X plus 4. And this is really a shift left 4. So this graph goes left 4 and is reflected in the x-axis, or sorry, y-axis. So this is a great time for us to introduce this idea. This is why I generally try to avoid horizontal stretches and shrinks, because in order to see them, you actually have to factor them out. So let's graph those square root graphs. We're going to go left 4. In order for there to be a reflection in the y-axis, instead of plotting your other points to the right, now we're going to plot the other points to the left. But there's, again, no stretch or shrink. So we can just go up 1, left 1, up 2, left 4, reflect, draw a parabola. Okay, so there's my positive and there's my negative. There are 2 of them. So be on the lookout for that. I think there's one of those on the homework tonight where you have to factor out the negative. Okay, be on the lookout for that. It is really cool.
Awesome.
What's the vertex? Negative 4, 0, opens, left. Tell me about the domain.
X is less than.
S is less than or equal to negative 4 and range. Y is all real numbers. Remember, those are flip-flop from the x squared parabolas. In the x squared parabolas that we did early on, the domain would have been all real numbers. But now they're flip-flop because we switched x and y. Okay, questions or concerns? Okay, last one we're going to do a circle. Okay, circle should be easy. So looking at this equation, how can I tell immediately that it is a circle?
There is 2 squared terms.
X squared and y squared, both of them being squared, means that it is a circle. So when it is a circle, I want to try to get it to look like x squared plus y squared equals r squared. That's like my simplest form for the equation of a circle. Its center point is at 0, 0, and all of ours will be centered at 0, 0. So we want to add the x squared to both sides. So we have x squared plus y squared equals 25. That means our center point, our h and our k, is 0, 0. And our radius is what? 5. So remember, in the equation of the circle, this is r squared. Therefore, r is 5, the square root of that number. So then that's a pretty easy graph to make, right? Someone suggested plot your center, I think it was Logan. So let's put our center point down, 0, 0, and then just count out 5. I count in all 4 directions, right, left, up, down. So I'm going to go 5 to the right. I'm going to go 5 left. I'm going to go 5 up. And I'm going to go 5 down. And I'm going to draw a perfectly round circle. Don't draw a diamond. Thank you. I'm impressed too. Oh, it is a little wonky, but that might be the graph that I chose.
Yeah, that's pretty good. Especially on a smart board.
I should sometime, like after school, have a competition. Students can come and try to draw the perfect,
Right after this class, right?
most perfect circle.
I think I could draw a problem.
Okay, let's finish domain arrangement. TJ's gonna try to outdo me.
I got this.
Okay, domain and range. Tell me about the x's. Yeah, you're kind of like sandwiched in between the sides of the circle. So we're going to start with the lowest x that works. The lowest x is -5. Must be less than or equal to x, which must be less than or equal to 5. So always put the lowest number left, and they're both less than, so they don't change. So that says in between. And what about y? Same thing. Yep. So that's kind of like a new domain and range that we really haven't encountered yet, where it's like stuck between two things. It doesn't have the arrows. Okay, so I can erase my circle, and then you're going to draw a better circle?
Yeah.
Go, let's do it. TJ, if you can draw the circle, then we all get an A.
Yeah, TJ draws a perfect circle.
No, you're trying to sabotage me. Make a point that you
You can't
I get
draw a
it.
circle.
I fixed it, so obviously I was not sabotaging anybody. You don't trust me?
He's preparing himself.
Well, he's had more time to look at it, and he's shaking out all his critters. And I
Hey,
didn't
TJ
do that.
draws a perfect circle, no final.
Oh gosh, this is way harder than I think now.
Yeah, we get shadow.
My circles are always so bad.
I think it's
No.
a little too
Oh,
round.
yeah.
Alright.
Oh.
Alright,
Oval.
here, if you think TJ has a
good at
perfect
first.
circle,
He had a more well-rounded circle.
so you're cheering?
Yes,
Thank you, Liam.
I got you.
Here, if you think Miss Conky's circle is better.
Okay,
Okay, because someone wooed, it sounds louder for TJ.
Okay.
It was definitely me.
It's like,
TJ is just a little.
That size.
got
It's
the
like
size.
a straight line.
Right though.
It's no good.
It was like a
volunteer.
rise
I'll
to the rest of the class. Every single one
I
of those
volunteer. I
looks
will
similar
usurp
to the
your
one
throne.
before.
Oh, and it's too weird on the top.
I
Yeah,
volunteer.
my bottom left one was really good.
Okay, let me stop my recording and then someone else can
I
try to draw a
volunteer.
perfect
Look,
circle.